What's beyond ChatGPT? LLMs to world models. AI has experienced unprecedented growth and advancements in recent years. However, despite the success of large language models, LLMs, there are still limitations to their capabilities. LLMs excel in processing and understanding human language, but fall short in truly interacting with the physical world and adapting to changing environments. To bridge this gap, researchers have begun exploring the concept of world models. Texts are relatively a new invention. According to Moravec's paradox, it is easier for machines to mimic recent human capabilities like manipulating texts than much older capabilities such as vision and other types of sensing. AI researchers like Fei-Fei and Yann LeCun are both independently working on world models that aim to equip AI with a deeper, more structured understanding of the world that extends beyond text. In a recent panel discussion at IIT Delhi, Yann LeCun argued that true human-like intelligence cannot be reached by merely increasing the size of current large language models, and that a better understanding of the physical world through innovative designs is crucial. Origins of world models. While the concept of world models is relatively new, the idea of creating intelligent machines that can interact with the physical world dates back to the early days of AI research. In recent years, novel approaches have been introduced. These include the use of generative recurrent neural networks to learn compressed representations of environments and the development of a model-based reinforcement learning agent capable of learning long-horizon behaviors through latent imagination. It is now becoming popular by well-known researchers like Yann LeCun and Fei-Fei. Why world models are needed. LLMs have limitations because they are primarily focused on language processing and pattern recognition, rather than developing a complete model of intelligence. World models, on the other hand, aim to equip AI systems with the capacity to understand and interact with the physical world. This kind of intelligence is critical for applications that require interaction with the real world, such as robotics, self-driving cars, and any scenario where an AI must react to physical or temporal shifts. By incorporating real-world interaction, predictive planning, and adaptability, world models can truly revolutionize the way AI systems function. For instance, a self-driving car using a world model can predict the behavior of pedestrians, other vehicles, and road conditions, allowing it to navigate safely and efficiently. Impact of world models. The impact of world models on the future of AI is immense. As world models continue to evolve, we can expect to see more sophisticated and interactive AI systems that can adapt to changing environments. This could lead to breakthroughs in various fields, including better LLMs, robotics, autonomous vehicles, and healthcare, leading researchers in world models. Several researchers are actively working on world models, each bringing their unique approach and expertise to the field. Two of the leading researchers in this area are Fei-Fei and Yann LeCun. During the launch of World Labs on September 13, 2023, Fei-Fei announced the Large World Model, LWM. The goal of the LWM is to develop spatially intelligent AI that can understand and interact with the world in 3 dimensions, moving beyond traditional 2D interpretations of data. This model is related to her earlier concept of the mind's eye, which emphasizes the importance of creating AI that can reason about objects, places, and interactions in a way that mimics human spatial awareness and understanding of the physical world. Joint Embedding Predictive Architecture, GEPA, proposed by Yann LeCun, is a self-supervised learning approach that predicts missing parts of an input by jointly embedding representations of different parts, enabling the model to learn rich and meaningful representations without requiring labeled data. Similarities between LeCun and Lee's approaches. Despite their differing approaches, LeCun and Li's work shares several commonalities. Fei-Fei Li and Yann LeCun both emphasize the importance of spatial and temporal modeling in AI, aiming to provide systems with a structured understanding of the world. Li integrates multimodal data, text, images, and video to create a comprehensive 3D model, while LeCun's approach allows agents to learn through self-supervised experiences, mirroring how animals adapt to their environments. Both methods enhance AI's ability to predict and react to changes over time, equipping them with capabilities to understand and navigate complex, real-world scenarios. Another key similarity lies in their focus on predictive and planning capabilities. Both researchers aim to develop AI that can forecast outcomes based on actions taken. LeCun's model predicts future environmental states, facilitating anticipatory behaviors, such as navigating obstacles. Li's model utilizes real-world data to generate spatially accurate simulations, enabling informed decision-making. Both approaches advocate for a transition away from traditional supervised learning methods, promoting self-supervised learning that emphasizes observation and interaction for broader applicability. Other researchers working on world models. Several other researchers are actively working on world models, bringing new ideas and approaches to the field. Some notable examples include David Ha and Jürgen Schmidhuber. These researchers created a model that learns compressed representations of the environment, allowing for more efficient navigation and interaction. Danijar Hafner and Timothy Lillicrap. They developed Dreamer, a model-based reinforcement learning agent that can learn from image observations, allowing for more effective decision-making. Estimated timeline for world model development. While it is difficult to predict exactly when world models will become a mainstream technology, it is likely to take several more years to see the first commercial model. As advancements continue to be made, we can expect to see world models increasingly integrated into various applications. Key takeaways world models address: LLM limitations. World models address the limitations of large language models, LLMs, by incorporating real-world interaction, predictive planning, and adaptability, critical for physical applications. World models are essential for applications that require interaction with the physical world, such as robotics, self-driving cars, healthcare, and cases requiring reaction to physical or temporal shifts. Conclusion: world models represent a significant leap forward in AI research, pushing the boundaries of what is currently possible with language-based models such as ChatGPT. As this technology continues to evolve, we can expect to see more sophisticated and interactive AI systems that will change the way we live and work. Like, subscribe, or share if you want to support content like this.